Alright, here is my DIY Dremel CNC machine. It consists of a construction of aluminum extrusions that are 600 millimeters long on each end. Likewise, I used a plywood base plate that is cut to size on each side, just to give it more of a rigid structure. So it's very stable and very rigid at this point. In order to hold all the aluminum rods and all the axes, all the sliders, I used CAD and printed all these brackets on my 3D printer. They house the motor, they hold the rods, and they hold all the axes in place along with the bearings. All the sliders, all the axes are driven by stepper motors, 4 of them, 2 for the x-axis, 1 for the y-axis, and 1 for the z-axis. So all these stepper motors are going into a CNC shield that are connected to a Arduino Uno. What's going on in here is there is a free open source software called Gerbil. What software does is it converts computer code into PWM signals for the stepper motors to follow directions to. Alright, for the heart of the machine, here is the tool holder assembly Z-axis module. This currently holds a Dremel. The cool thing about this design is that I made it modular with other tools that you could swap out. For example, here's a Dremel for milling and drilling, and here is a laser module that could be used for cutting wood or engraving. Alright, now I want to give a little demonstration of the live feedback of information between the computer and the machine in terms of like axes input and the corresponding output on the machine. It's going to zero out all the axes and display our parameters in terms of speed, feed rate, and the positions. And here we can see our current positions where it's homed to 0, 0, 0. We can kind of change this as you can hear the motor start moving, and we're getting a live feedback of the position of the tool head. Alright, so we imported the file into the software. Now we're going to turn on the Dremel and run the code. Woo. Alright, here is the final product. The finish isn't great on this just because it's cheap craft wood, but we gotta do some sanding. Alright, after a simple sanding job, our bracket is finally done. Test this piece for accuracy. So now it was supposed to be 50 millimeters in width, getting 49.7 on this side, 49.9 on this side. So very, very close to that tolerance we were aiming for. Alright, at this stage I will be swapping from the Dremel to the laser module in order to demonstrate its engraving capabilities. I will be engraving a small UCSD Trident logo on the bracket we just made, just to add another layer of manufacturing process. Alright, now that we have successfully swapped into the laser module, we will see what we can engrave. Alright, before everything, we first need to put on some glasses. And second of all, we need to focus the laser beam to a fine point. Alright, once we're happy with the focus of the laser, we're gonna go back into the program, and so we'll proceed to engrave. In principle, the laser module works very similar to the CNC module, but here I utilize an extra PWM port on the CNC shield to allow for laser power control. Now, the G-code you see on the left is raw machine code instructions that tell the laser where to move in the XY plane, as well as when to modulate the power output at precise time intervals. Alright, I hope this little demonstration gives you a little bit of insight on the possibilities of this machine, the interchangeable modular design of the tool head. We ran through a milling process as well as an engraving process with the laser module. And so this is my project, the Dremel CNC machine